Students, today we will solve question number 12 to 15 from exercise 5.1 from NCERT Mathematics class 12. So without a further ado, let's get started. Look at the question. Question is question number 12. X is equal to x to the 10 minus 1 if x less than equal to 1, x square if x greater than 1. We have to find all points of this continuity of f here. So solution here we can case 1. Case 1 x is less than 1, x is less than 1. So when x is less than 1, so FC will be c to the power 10 minus 1 and limit x tends to c fx is equal to c minus 10 minus 1. Therefore fc is equal to limit x tends to c fx. So therefore fx is continuous, fx is continuous in this case. Case 2. Case 2. In case 2, if we will take x greater than 1, so in this case also fc is equal to c square and limit x tends to c fx is equal to c square. So here also f c is equal to limit x tends to c fx, therefore fx is continuous. Fx is continuous in this function. So now case third. Case third. Now we will check the continuity at x when x is equal to 1. On this, at this point we will check continuity. So fx f1 is equal to, function is what, f1, when f1 will be 1, so this will be x to the power 10 minus 1. 1 to the power 10 minus 1 means 1 minus 1 is equal to 0. Now left hand limit fx, we will find a left hand limit. To left hand limit we will use this function if it is less than 1, so this will be x to the power 10 minus 1. X to the power 10 minus 1. So this will be 1 to the 10 minus 1 is equal to 1 minus 1 is equal to 0. Now right hand limit. Right hand limit will be, so we will use this function x is greater than 1, so x square, that function we will use. Limit x square, this will be put value 1 square, so it will be 1. Here we see that left hand limit is not equal to right hand limit. So therefore, fx is not continuous x is equal to 1. So this is the only, so 1 is the only this is at x is equal to 1, so fx is not continuous at 1. So this will be the answer. Now question number 13. Question number 13 is the function defined by this a continuous function is fx is equal to x plus 5 if x is 1, x minus 5 if x greater than 1. So here is the function defined by this is a continuous function. This we have to check. So here case 1, case 1 case 1. In this case x is less than 1. When x is less than 1, so this function is continuous. Case 1 fx is continuous in this case. Case 2 x is greater than 1, so fx is continuous in this also. Case 3 x is equal to 1. At this we have to check the continuity. So f1, first we will find f1. f1 will be 1 plus 5 is equal to 6. Limit left hand limit. Left hand limit will be, so less than 1, so we will use this function limit x tends to 1 minus f we will use, this is x plus 5 is equal to, if we put value 1, so this will be 1 plus 5 is equal to 6. Now find a right hand limit. Right hand limit will be x tends to 1. So if it is greater than, so we will use this function x minus 5. If we put value 1, so 1 minus 5 is equal to minus 4. So here we see that left hand limit is not equal to right hand limit. So therefore fx is not continuous at x is equal to 1. Now see question number 14. Question number 14. Discuss the continuity of the function f, where f is defined by fx is equal to 3 1 4 5 So here discuss the continuity of the function. We have to find continuity of this function. Case 1. 0 less than 1, less than 1. In this case, fx is continuous. Case 2. One x3. In this case also, function is continuous. Case 3. Then fx is continuous. Case 4. X is equal to 1. At 1, we will have to check the continuity. So first we find f1. So f1 will be 3 and left hand limit if it is less than 1, so this will be 3 and right hand limit greater than 1, so it will be 4. So here we see that limit here we see that limit left hand limit is not equal to right hand limit. Therefore fx is not continuous at x is equal to 1. Case 5. Case 5, x is equal to 3. So we will check continuity at 3. So f3 is equal to 5. and left hand limit if it is less than, then less than fx, left hand limit will be what? Less than 3, so this will be 4, and right hand limit more than 3, so it will be 5. So here also we see that limit, left hand limit is not equal to here will be not equal, not equal to right hand limit. So therefore fx is not continuous at x is equal to 3. So here we see that function is not continuous at x is equal to 1 and 3. Question number 15. X is equal to x if x less than 0, 0 if 0 1, 4x if x greater than 1. So in this case we have to check continuity. So case 1, x is less than 1. When x is less than 1, so function will be fx is continuous. Case 2, x greater than 1, fx is continuous. Case third. So zeros 1 greater than 0 and less than 1. So in this also fx is continuous. Case 4. X is equal to 0. So we will have to check the continuity at x is equal to 0. So f0 will be 0 and left hand limit less than 0. So less than 0 is we will use this formula. We will put value for 2 into 0 is equal to 0. Right hand limit greater than 0. So greater than 0 will be 0. So here we see that f0 is equal to limit x tends to 0 fx, because left hand limit and right hand limit is same. Therefore fx is continuous at x is equal to 0. Now we will check continuity at 1. So f1 case 5. X is equal to 1. So we will check f1. f1 will be 0. Now left hand limit less than 1. So less than 1 will be 0. Right hand limit over x. So here we see that left hand limit is not equal to right hand limit. It is not equal to right hand limit. So therefore fx is not continuous at x equal to 1. I hope you must have understood these solutions. Today up to here. We will meet in the next section with next questions. Till then, take care. Thank you.